Welcome back. Today we will be doing lecture 6. Happy to have you. Lecture, we looked at the detail of the journey of Faxin as he made his way in the 5th century around the rim of the Great Circle. His story informs us of the presence of large seagoing vessels in the Bay of Bengal and the seas off Southeast Asia, crewed by sailors from the western regions of Eurasia. Understanding the significance of these accounts requires a look at the period during which sea travel and trade had developed to this degree. How did mariners come to make a profit from long-distance trade? What was the cultural and social pattern that marked the lives of the South Asian merchants who were passengers on board the vessels from the western regions of the continent? And what role did Buddhism play in this communication system? The commercial interaction between distant places was activity driven by consumer demand for items not available locally. Trade flowed from ancient times down rivers to seaports or along hinterland ports often connected to river systems. Each of these methods of transportation required some form of energy. In the days of early Buddhist dissemination, there were only a few sources of power for moving cargo from one place to another: river currents, ocean winds, and tides, as well as humans and animals. There was no other mechanism other than winds, currents, and muscle for travel. While there were backpack traders serving local communities, human bodies are not capable of moving a large amount of goods for commercial trade over long distances. The roads were often caravan routes, where camels, oxen, and horses each could move several hundred pounds of cargo. In order to make the transport profitable, there were caravans of many animals being moved en masse, laden with goods. Even with the large number of animals being used to transport goods, it was not an efficient procedure. Caravans could usually only move along a relay system, with the merchandise being loaded and unloaded as it was transferred from one merchant to another within a trading circuit. The process was expensive and slow. Relay did have the advantage of allowing merchants to move back and forth within a limited range of travel, and thus remain nearer home and in areas where they understood the languages. It was rare for the same animals and personnel to traverse hundreds of miles. Most caravan merchants traveled back and forth over familiar territory, often in segments that could be covered within one day. It was possible for goods and people to accompany the traders on these inland routes. But if they wanted to go beyond the local trading circuit, it meant making use of multiple relay transfers involving numerous contacts. In Inter-Asia, just such trade patterns provided a means for individuals to move from one relay circuit to another and make a journey of thousands of miles, all the way from China to India. The cheaper and faster medium for commercial travel was water. either rivers or sea. While a camel might carry as much as 300 pounds, ocean-going ships could have 400 tons or more on board. When sailing across the open sea, ships moved 24 hours a day, while animal caravans had to pause each day for rest and food. The Orbis research project at Stanford University, studying how grain was shipped to Rome, gives us proof of the difference in cost between land and water. Grain that was more than a few miles from water portage was too expensive to ship. The data shows that this was true throughout the Mediterranean basin. We can only imagine how much expense and time would be involved in the transport of goods 5,000 miles across land from China to the Mediterranean. In the past, the difficulties of making an income from the limitations of long-distance land travel was explained by the idea of high-value, low-volume items. This is not the case for sea travel, where the opposite was true. Low-value, high-volume was the source of much of the wealth. We see this most recently in the artifacts of the shipwreck at Belitung, where 60,000 items of mainly low-value ceramics were being sent from kilns of China to Persia. The ship's cargo had a relatively small amount of high-value, low-volume cargo, indicating that ships could and would carry both types of merchandise long distances. Perhaps the best example of high value, low volume product would be aromatic musk, where a few ounces had much value since it could be diluted to minute amounts and still be usable. However, the international trading system of hundreds of ships and thousands of sailors, with even larger number of port personnel, was never designed for low volume. Trade, whether on land or sea, was made up of circuits of travel where merchants made regular round trips. Income was generated by the trade within that circuit. The trade was partly based on high value, low volume objects. However, it's hard to imagine how local merchants could have survived week by week without exchange that gave them some immediate income. The local trade sustained them, while passing along silk, precious stones, and rare objects gave some profit. The payment must eventually have been made in barter for merchandise available to and needed by those who came to the market towns. In the pre-industrial age, water current was the major source for energy, since it could provide both flotation and downhill movement. Now, while the sea carried people and goods away from river mouths, the flow of water coming down from the hinterland was a crucial aspect of transport. The rivers were best used to move objects toward the sea, while going against the movement of the water to transport upstream was a much more complicated and expensive venture. Many rivers have a tidal pattern, which can reverse the flow and help vessels move for short distances inland. And in most cases, animals and humans had to provide the muscle power to take the boat back upstream. The most efficient post-pre-modern transport was one in which it was possible to combine wind currents and water. And that was the advantage of the maritime systems of trade. There are water currents in the oceans, but they're secondary to the power of wind for moving vessels long distances. In the maritime world, at least, it took centuries for sailors and other observers to gather and pass on information about the nature of the winds that fill the sails of their ships. For example, the observation that a regular yearly pattern of wind blew across the Indian Ocean allowed people to plan and profit from trade using ships that rode across the sea pushed by air currents. Today, we refer to this pattern as the monsoon winds that blow for 6 months west to east, then reverse and go from east to west. For any journey across the sea, it is crucial to have knowledge of the speed and location of this energy source. West Asian seamen were probably the first to know of the yearly cycle of winds between Africa and India. Greek sailors also looked for information about the monsoon, and in 120 before the Common Era, Hippolytus is said to have clocked the speed of those winds. Well, once they'd measured the velocity of seasonal winds across the Indian Ocean, they were able to calculate the use of these energy currents. They discovered that the speed of the wind and the length of time it blew in one direction was fast enough to make a journey from the Red Sea to the eastern shores of India within the space of time that ships could provide sufficient food and water for those on board. With this data in hand, they had the assurance to set up regular sailing circuits that extended far beyond the coastline. Knowing the wind speed and regularity, they knew it was possible to sail from the Horn of Africa across the Indian Ocean to the western coastline of India within the period of the summer monsoon season. The monsoon winds were like wind rivers that permitted the sailors using them to estimate their landing spots. Since longitude was not yet a part of the available information for land travel, it was easy to lose one's way on the open sea. However, with the predictable flow of winds from the Red Sea to the Indian shores, navigation required the vessels to hold to latitude 120, which would take them from Africa to the Malabar coast. In one sense, they had to merely remain in the wind and allow it to blow them on its track. The knowledge of the subcontinent described by the Greek geographer Poseidonus, 100 BCE, established that the orientation of the landmass of India was north-south. That meant that it extended far south of the Persian coastline. And one could sail across the Indian Ocean with the comfort of knowing that India was hard to miss. Now, because the flow was known to reverse and blow at the same speed in the opposite direction during winter, they could plan to go from the Red Sea to India and return within a year. In this way, Persians, Arabs, Greeks, Indians, Greco-Romans made long-distance sailing a reality and helped to drive the maritime trade to new heights of importance for the whole of Eurasia. When Strabo, the Roman historian, traveled to southern Egypt in 26 BCE, at the beginning of the monsoon season, he was told that 100 or more ships were anchored out at sea, waiting for the winds to arrive and carry them to India. The wealth that was being carried back and forth in this fashion was an important element in the trade patterns that developed from ports in India and Sri Lanka that served as entrepots for the routes going further to Southeast Asia and China. Now, the monsoon pattern is created by a buildup of pressure over Inner Asia. It is the heat of spring and summer on the Tibetan Plateau when the high pressure pulls in air that causes the wind to blow from India toward India from Africa. Now, since the source of the attraction is fixed by the location of the high pressure, the direction of wind is always toward or away from Inner Asia. When the fall brings cooler weather and the pressure begins to lessen, a reverse flow of air moves from the land across the sea. The caravans that traversed Inner Asia were, in one sense, moving through the zone of high and low pressure that provided energy to the distant seas for maritime trade. Well, monsoon annual wind patterns also occur on the east coast of India and the South China Sea. Although the monsoonal winds were a predictable annual occurrence, it was not possible to sail from India to China in one monsoonal season. This made the early ports of Kedah, Jambi, Malacca important layovers as the merchants waited for the winds to change. From May to October, the southwest monsoon blows across the Indian Ocean through the Andaman Sea. So ships departing from Sri Lanka or southern India would travel eastwards, making landfall along the Thai Malay Peninsula. From October to December, the northwest monsoon blows in the opposite direction that allowed Chinese ships to journey to Southeast Asia and beyond. A trading enterprise from India to China, based on the various currents of winds over the Indian Ocean and up into the South China Sea, could take up to 3 years to complete. Indian ships could be found crossing over monsoon patterns and making a journey from Africa to the trading polities on the Malay Peninsula. From Sri Lanka to Champa, that is current-day Vietnam, mercantile enterprise was dominated by Southeast Asian vessels called Colombo and Jong, and Arabic ships Dhow. China remained the major destination for trade goods and mercantile exchange east of India. Now, maritime activity was based on both short coastal sailing circuits, as well as those depending on a yearly weather calendar when winds could be used to cross long distances of open sea. The coastal circuits were primarily sailed for fishing. Boats that set out from harbors in these instances stayed within sight of landmarks and made their way with daily wind patterns blowing along the shoreline. Water currents caused by tidal flows and the use of sails to tack into the wind. But these strategies were of little use if one wanted to cross the entire sea and be without sight of land for weeks at a time. While the monsoons were the force and the direction needed to move ships across the open ocean, these winds were not always positive. They could be destructive. For example, cyclones and typhoons generated each summer as part of the monsoon season battered the Bay of Bengal, as well as the eastern coast of China. There was no way to predict the storms or to chart their course. Ships caught up in these violent storms were often either sunk or blown beyond their intended routes. In 748 of the Common Era, Jin was blown off course by a typhoon and found himself on the southeast coast of Hainan Island rather than northern Java. Well, in spite of all the difficulties, the various connections between China and India have been consistently used, with shifting patterns of activity over centuries of time. Ways were found to overcome the challenges, whether on caravan routes or sailing circuits. It is particularly true that the sea trade between the two regions, extending across the Indian Ocean, continues to be of importance into the present century. The large number of ships coming down the Red Sea and sailing around India and Sri Lanka, heading to Chinese ports, are following the ancient flow of trade. Well, by contrast, the old inter-Asian caravan trade and its routes have ceased to be of significance. However, a revival of sorts can be seen in the recent railroad construction between China and Europe that passes through Inter-Asia. While trading patterns can be found wherever humans existed, it is important to remember that these may thrive for a time, and then with shifting political, cultural, and technological advances, the routes and settlements along them may be abandoned, and all we possess of past glories are ruined archaeological remains. The process of the rise and fall of human settlements is an integral part of the data related to the cultural context between South, Inner, and East Asia. These are some of the factors that help to forge the maritime routes: sailing technology, navigational skills, and the profitable trading circuits that Faxin found when he boarded a ship in the Bay of Bengal. Thank you very much. Glad to have had you at this lecture. I'll look forward to seeing you for Lecture 7 coming up.